Hi guys, this is Himanshu Verma. I hope you guys are doing well. Today I'm going to be explaining you Kadane's algorithm. So Kadane's algorithm is a very crucial algorithm in data structure to find the maximum subarray sum in linear time. So let's first try to understand what is in subarray in array and how to find the maximum subarray sum, right? So a subarray is a contiguous part of an array, any contiguous part without losing any values in between. That is basically an subarray, right? For example, this is in subarray, this is in subarray, right? A single element can also be considered as a subarray, right? But this minus 2 and 2 leaving this value 4 cannot be considered as a subarray, right? So now you know what is a subarray. Subarray is basically a contiguous part of the array, right? So now let's try to understand how we can find the maximum subarray by generating all the possible subarrays. So let's try to approach this and let's try to generate all the subarrays using the brute force, right? So the first way is to try the brute force. So the brute force way is to like generate all the possible subarrays. For example, if I am at the starting index, I can consider this element itself or this subarray, this one, this one, this one, this one, or this one, right? When I'm at this index, I can consider this one, this one, this one, this one, or this one, right? Similarly, for the remaining elements, we can generate all the subarrays. So the brute force approach is simple. Just need to run two loops. The first loop will be keeping track of the current element, and the second loop will iterate from that current element to the size of the array to make sure to generate all the subarray for that particular index, right? So let's write the pseudocode. For example, we're gonna be having the outer loop running from 0 till the size of the array, right? And the inner loop gonna be running from I to the size of the array, right? And we can keep track of the sum using a sum variable, right? And we can take the sum of that particular subarray using this sum variable. And we also need to make sure to take a maxi variable outside both the loops to take maximum of all the possible subarray sums every time to get the maximum sum, right? So maxis could be initialized with a large negative value. Why a large negative value? The large negative value is required because the whole subarray can have a negative sum, right? So if whole subarray has a negative sum, we need to make sure that we take the minimum negative value or minimum negative sum. That is why we need to initialize the maxi with a large negative value, right? So every time we take the sum for a particular subarray, we need to make sure to take the maximum, right? So this will make sure that every time the sum is taken maximum, right, for every subarray. Now let's try to write this pseudocode and try to submit this, right? So this is the brute force code to find the maximum subarray sum for an array, right? So we have declared two variables, variable n, which basically stores the size of the array, maxi, which basically is initialized with a large negative value to make sure that if the array contains all values which are negative, in that case the minimum negative value is considered, right? That's why we haven't initialized the maxi with 0. And max is also used to keep the track of maximum subarray sum every time we find the sum of that particular subarray. So we are running an outer loop from 0 to n and an inside loop from I to n, right? So basically the outer loop makes sure that the subarray is being calculated from that particular ith index till the end of the array, right? For example, if I is pointing at minus 2 or at 0th index, it considers this minus 2, this minus 2 minus 1 array, then this minus 2 minus 1 minus 3, then this array, then this one, then this one, right? So it makes us that it covers all these subarray that starts from I equal to 0th index. And when I points to 1 index, it makes us to cover all the subarray that starts from I equal to 1 index, right? The inside loop makes us to take the sum of all the possible subarrays starting from I equal to 1 index, right? And that is how all the subarray are being calculated and the maximum out of all, right? The subarray which gives the maximum sum is being considered, right? And then we are returning the maximum sum. So let's try to run this and see if it works. So yeah, we can get the correct answer as you can see. Now let's try to submit this and see if it gets accepted. So have a look. So we got a TL, right? So we need to make it optimized to work in linear time as we have large constraints, right? And to pass the solution in linear time, we need to write a code that works in linear time, right? So this solution works in O of n squared. So let's have a look how we can optimize this brute force to work in linear time using Kadane's algorithm. So let's go back to Notepad and have a look. So let's try to consider this example, right? And let's try to find the maximum subarray in linear time. So let me try to explain your concept, which is important, right? For example, you have a array minus 2, minus 4, and 10, right? This is array. So if I ask you what is the maximum subarray sum you can get from this, so the answer will be very simple, 10, right? So how it is being how it is being calculated. So for example, if I take a sum variable, if I add this sum, it will be minus 2, right? If I add this minus 4, the sum becomes more negative, right? So if the sum becomes more negative, it will not gonna be like increasing in future. It will be decreasing, right? Why? Because we are adding more negative value to the current sum, so the sum becomes more negative. So it does not make sense to add more negative value to the sum. The better we can do is whenever the sum becomes negative, right? For example, the sum is negative, and when we are at this index, the sum becomes more negative. So if the sum is negative, we can reset the sum to 0 and start fresh again from this index, right? So for example, we have sum which is like -2, right? The sum is negative, so we reset the sum. And at the next iteration, the sum becomes -4, right? And again, the sum is negative, so we reset the sum to 0. And at this point, we again start from fresh, and because the sum is positive, we get the maximum sum from this array, which is 10, and which is the only answer we have, right? So what we have concluded from this is that if sum is negative, adding more negative value in future will decrease the sum, right? So it does not make sense to like add negative values or make the sum negative, right? Because it will decrease the sum in future. So the best way is whenever at any index, if sum becomes negative, reset the sum to 0 and start from fresh. Let's try to drive in the same logic in this test case and see if it works, right? So let's erase this. Let's try to run, right? So let's do the same thing what we have done in brute force. Let's take a sum variable which is initialized with 0 and a maxi which is initialized with a large negative value, right? Okay, so the sum is -2 initially. So maxi is also how much? -2, right? At this point, the sum becomes -4, which is negative, right? So the maxi still remains -2. And as the sum is negative, we reset the sum to 0 and start from fresh, right? And basically, till here the sum was -2. We reset the sum to 0. Now, at this point, the sum is -6. There's going to be -6, right? Because whenever the sum is negative, it does not make sense to add negative to negative to make it more negative. Reset the sum at this index, and at the next iteration, start from fresh. So we have sum as -6. Maxi still remains -2. At this point, as the sum is again negative, we will reset it to 0, and at this point, sum becomes -3, and the maxi remains -2, right? And again, at this point, the sum is negative, we will reset it to 0, and we'll start from fresh at next index. So at next index, we have sum as 4. So the maxi becomes 4, right? True. And at this index, the sum becomes 3, which is again a positive sum. So yeah, maxi again remains 4, right? Now at this index, we are taking this 2, and the sum becomes 5. Sorry, this is going to be 5, right? So the sum becomes 5, and maxi becomes 5. At this index, the sum becomes 6, and maxi also becomes 6, right? Now, at this index, if you see, again 6 minus 5 will be 1, a positive sum. So again, we can like consider this sum, right? And the maxi becomes 6 only, right? Because we haven't found any greater value, right? And at this index, if you see, the sum becomes 5. Let's write it down. Sum becomes 5, and maxi still remains the same, which is 6. So we got maxi as 6, which is nothing but the maximum subarray sum for this subarray, right? And which subarray part gives this maximum sum is basically if you consider this till this, if you consider this, we can see that 4 minus 1 becomes 3, and 2 5, and 1 6, right? So this particular part of the array, which is basically a subarray, gives the maximum subarray sum. So we basically find the maximum subarray sum in linear time using Kadane's algorithm just by making sure that whenever the sum becomes negative, we reset the sum to 0 and start from fresh again and try to maximize the sum as much as possible until the sum is positive, right? So let's try to write the pseudocode. So we will just take two variables as we have shown in Dryden, sum and maxi, right? Maxi is initialized with a large negative value. We will run a loop from 0 to the size of array. We will take the current sum, which is nums of I, right? Every time we will try to maximize the sum, right? And we will make sure if sum is negative, reset it to 0, right? So this is nothing but the pseudocode, which will make sure to find the maximum subarray sum in linear time. So let's look at the code. Let's go back to leetcode and let's write the optimal code. So we're gonna be removing this loop, the sum variable, and we can just declare the sum variable outside initialize with 0. We can just add the current value to the sum. We need to make sure that we take maximum of all the sum, right? And this is very crucial step. If sum becomes negative, we need to make sure that it is initialized with 0 or reset to 0 so that we can start from fresh again and take the maximum, right? Let's try to run this code. So I think we can see that it works. So let's try to submit. So it got accepted and we beat 100% of the users in runtime. Okay, so some of the students may have a doubt that why initialize with a large negative value, why not initialize with 0 or why it is required. So whenever we will have like all negative values in the array, right? The overall sum will be negative, so we need to consider the minimum negative value. So that is the reason why we need to initialize the maxi with a large negative value, right? So that we can get a maxi with a negative value, right? Minimum negative value. And this is also required that we need to reset the sum to 0 at last so that we can consider the negative minimum value when all the elements are negative in the array, right? So this is nothing but your simple Kadane's algorithm, which can be used to find the maximum subarray sum in linear time. So now I'm gonna give you some questions which are very much related to Kadane's algorithm. So the first one we have already solved, right? The second one is this one. So let me open this one. So this is nothing but maximum absolute sum of any subarray, which requires Kadane's algorithm to solve this. So you can try this one. and this one is a medium difficulty one. It also required Kadane's algorithm to be solved, right? And the third one is a very hard question from CodeChef contest, a recent contest, which requires Kadane's algorithm, greedy, and some mathematical skills to be solved, right? So this all three questions you can try to master Kadane's algorithm. Yeah, so I'm gonna be discussing what will be the like real world application of this Kadane's algorithm. So Kadane's algorithm can be used to like find the best period to buy and sell stocks for maximum profit, right? We can get the maximum profit by identifying the subarray with the highest sum of price differences, right? And it can also be basically it is very much used in the competitive program, like right. So for example, this question was one of the contest questions of recent contest, which uses basically the Kadane algorithm to like get the maximum net gain of that particular element, right? It is also like required to solve some of the questions in your leetcode contest, right? So it's a crucial algorithm, right? So you can make sure to like solve some practice questions based on Kadane's algorithm to master it. And I'm gonna be meeting you in the next class. So have a good day, take care, and